Hello, my dear students. Today we are going to continue chapter 5, which is organic chemistry. We are going to continue our discussion on hydrocarbon derivatives. We are going to discuss today the carboxylic acids, aliphatic acids, and aromatic acids. We are going to discuss their preparation and physical properties and chemical properties and their detection. So let us start. Carboxylic acids. Carboxylic acids are considered the most acidic organic compound. Carboxylic acids are not strong acids as in organic acids, for example, sulfuric acid. Carboxylic acids form homologous series which are characterized by the presence of one or more carboxylic group, COOH group. So the carboxylic group is the functional group of organic acids. Here, my dear student, the carboxylic group composed of two groups, carbonyl group C double bond O and hydroxyl group OH group. Here, the carboxylic group may be attached to an alkyl radical to give aliphatic acid, as shown on the screen are COOH aliphatic acid, as for example CH3COOH, which is acetic acid, or the carboxylic group may be attached to benzyl ring and give aromatic acid, as shown on the screen, aromatic acid called benzoic acid, that's C6H5COOH. We have give reason in this point. The saturated monocarboxylic aliphatic acids are named fatty acids. The reason for that, because they are present in fat in form of ester with glycerol. The types of carboxylic acids. The basicity of acids. Here the number of carboxylic group in an organic acid is its basicity. Here monobasic acids as formic acid HCOOH, also monobasic acid which is aromatic acid is benzoic acid C6H5COOH. Dibasic acid as oxalic acid C2O4H2, also phthalic acid as shown on the screen, benzyl ring attached to two carboxylic groups. Here we are going to discuss the nomenclature of acids. Common names. Carboxylic acids are derived from the Latin name of the source from which the acid is obtained. HCOOH is formic acid derived from ants, which formica, as it was prepared from the distillation of crushed ants. CH3COOH acetic acid is derived from vinegar or acetum. C3H7COOH, which is butyric acid derived from butter. C15H31COOH palmitic acid is derived from palm oil. IUPAC name of the acids derived from the alkane having the same number of carbon atoms by replacing the terminal E by suffix OIC acid, such that HCOOH methanoic acid, CH3COOH ethanoic acid, C3H7COOH butanoic acid, C15H31COOH hexadecanoic acid. The following table summarizes the common and IUPAC name HCOOH, its common name formic acid, iupac name methanoic acid, CH3COOH, its common name acetic and its iupac name ethanoic. C3H7COOH, common name butyric acid, iupac name butanoic acid. C15H31COOH, common name palmitic acid and iupac name hexadecanoic acid. Now we are going to discuss the acetic acid in details. The methods of preparation. The biological method: by oxidation of dilute alcoholic solution by atmospheric oxygen in the presence of vinegar bacteria. From acetylene, second way, that acetylene on catalytic hydration in the presence of mercury sulfate, sulfuric acid 60 degree, it gives acetaldehyde or ethanol CH3CHO as the equation proceeds on the screen. Then on oxidation of acetaldehyde or ethanol by the acidified potassium permanganate as shown on the screen CH3CHO, by oxidation with atomic oxygen it gives acetic acid CH3COOH. Now we are going to discuss the physical properties of aliphatic acids. From C1 to C4 are corrosive liquids to skin, having pungent irritating smell. We have give reason in this point. Aliphatic acids are completely miscible in water. Due to the formation of hydrogen bonds with water, and here the successive members are oily liquids, have unpleasant smell and sparingly soluble in water. As the molecular mass increases, they become solids and insoluble in water and odorless. We have give reason in this point. Boiling point of acids is higher than that of alcohols having the same number of carbon atoms. The reason for that, because each two molecules of the acid link to each other by two hydrogen bonds. As shown on the screen, two hydrogen bonds are formed due to the polarity of the carboxylic group. Here, two molecules of alcohol are linked only by one only hydrogen bond. As shown on the screen, the polarity of OH bond causes one hydrogen bond between the two molecules. Now, my dear students, we are going to discuss the chemical properties of ethanoic acid. The reactions which is specific to the hydrogen ion, the acidity and salt formation. The acidic property of carboxylic acids appear in their reaction with metals above hydrogen in the electrochemical series, and also with oxides and hydroxides, and also carbonate and bicarbonate salts to form organic salts. My dear student, notice that all carboxylic acids are weak acids. Their strengths are much lower than inorganic acid. Here, the example for the reaction with metal is the reaction between magnesium and acetic acid. As shown on the screen, it gives magnesium acetate and the hydrogen gas is produced as the following animation show. We are going to put some acetic acid in test tube, and then we are going to put piece of magnesium in it. We find that on adding magnesium on the acetic acid, the reaction occurs releasing hydrogen gas as shown on the screen. This reaction gives us that hydrogen gas is produced as replacing the hydrogen of the carboxylic group, and we can collect it and we test it as it burns with pop sound. Here, my dear student, if you look at the screen, here the gas is burning with pop sound. Here's the reaction with oxides or hydroxide. For example, the reaction of acetic acid with copper oxide. It gives copper acetate and water is produced, as shown on the screen. Or the reaction here of acetic acid with sodium hydroxide, it gives sodium acetate and water is produced, as the equation proceeds on the screen. Here the reaction with carbonates or bicarbonates. The reaction of sodium carbonate and acetic acid, it gives sodium acetate and the carbon dioxide gas and water is produced. Here this reaction gives carbon dioxide gas, cause effervescence and can turbid lime water. Also the reaction of acetic acid with sodium bicarbonate NaHCO3 gives sodium acetate and the carbon dioxide gas produced and water is formed. Now we are going to discuss the reactions that is specific to the hydroxyl group. The ester formation reaction. Aliphatic acids react with alcohol in the presence of concentrated sulfuric acid forming ester and water. As shown on the screen, general equation for the acids and alcohol RCOOH plus ROH. It gives here in the presence of concentrated sulfuric acid ester RCOOR and water, and here sulfuric acid is added to prevent the reversible reaction as it absorbs the produced water from the reaction. So acetic acid reacts with ethanol in the presence of concentrated sulfuric acid forming ethyl acetate ester and water. As the equation proceeds on the screen, acetic acid CH3COOH plus ethanol C2H5OH in the presence of concentrated sulfuric acid, it gives ethyl acetate ester and water is produced. Now, my dear students, we are going to discuss the reactions that are specific to the carboxylic group. The carboxylic acids are reduced by hydrogen gas in the presence of copper chromate at 200 degrees Celsius, and this reduction reaction is the opposite reaction of oxidation reaction of alcohols. As the equation proceeds on the screen, acetic acid plus hydrogen in the presence of copper chromate at 200 degrees Celsius, it gives ethanol and water is produced. Now we are going to discuss the detection of acetic acid. The acidity test. When acetic acid is added to sodium carbonate or sodium bicarbonate, effervescence occurs as the evolution of carbon dioxide gas. So when acetic acid is added to sodium carbonate or sodium bicarbonate, effervescence occurs due to the presence of carbon dioxide gas evolving from the reaction that can be tested by turbidity of lime water, as the following animation shows. Carbonate or sodium bicarbonate in beaker, and we are going to add an organic acid to it. We will find that the evolution of carbon dioxide appears as effervescence, and so you can test it. If you pass it on lime water, it will be turbid. So the evolution that occurs releasing carbon dioxide gas which turbid clear lime water. As the equation proceeds on the screen, acetic acid plus sodium carbonate, it gives sodium acetate and carbon dioxide gas and water. And then carbon dioxide gas reacts with clear lime water forming calcium carbonate and water is produced. The second detection of the carboxylic acid is the ester formation reaction. Acids react with alcohols to form esters which are characterized by pleasant odor, and they are responsible for the flavor of most of fruits of organic compounds according to the kinds of alcohol and the acid used. Now, my dear students, we are going to discuss the aromatic acids. They contain one or more carboxylic groups attached to benzene ring. Monobasic acid as benzoic acid, as shown on the screen. Dibasic acid as phthalic acid, as shown on the screen. The two carbon atoms of benzene ring are replaced by two carboxylic groups in two adjacent carbon atoms. Here hydroxyaromatic acids as salicylic acid, which can be named in IUPAC name 2-hydroxybenzoic acid. The preparation of aromatic acids by catalytic oxidation. Benzoic acid can be prepared commercially by catalytic oxidation of toluene in atmospheric air at 400 degrees Celsius and in the presence of vanadium pentoxide. As the equation proceeds on the screen, toluene on oxidation gives by vanadium pentoxide, benzoic acid and water is produced. The physical properties of the aromatic acids. Aromatic acids are stronger, less soluble in water and less volatile than aliphatic acids. The chemical properties of carboxylic acids, which are aromatic acids. Their reaction resembles that of aliphatic acids, as formation of salts on reacting with metals or with their oxides or hydroxides or carbonates. For example, benzoic acid reacts with sodium hydroxide, forming sodium benzoate, and water is produced as shown on the screen. Formation of ester on reacting with alcohols that we call esterification reaction. Here, benzoic acid reacts with ethanol in the presence of dry hydrogen chloride. It gives ethyl benzoate ester as shown on the screen, and water is produced. The organic acid in our life. Formic acid, HCOOH. It is the acid which is secreted by ants to defend themselves. It is used in the manufacture of dyes, insecticides, perfumes, and drugs and plastics. Acetic acid, CH3COOH, which is pure 100%. It is colorless liquid, corrosive to skin, and has pungent odor. It freezes at 16 degrees Celsius, forming solid substance as ice. Therefore, it is called glacial acetic acid. Acetic acid 4% is used as vinegar in homes. It is considered as a starting material for synthesis of many organic products, for example, synthetic silk, dyes, insecticides, and food additives. Benzoic acid, C6H5COOH. It is sparingly soluble in water. It is converted to its sodium or potassium salts to become soluble in water and easily absorbed in human body. We have give reason in this point. Sodium benzoate 0.1% is used as preservative substance for food. The reason for that, it prevents the growth of fungi on food. Citric acid has molecular formula C6H8O7. As shown on the screen, has 3 carboxyl group attached to 3 carbon atoms and one of the carbon in the middle attached to hydroxyl group. It is found in fruits in percent 5 till 7% and in lemon and 1% in orange. We have give reason in this point. Citric acid prevents the growth of bacteria in food. The reason for that, because it decreases their pH. Another give reason in this point. Citric acid is added to frozen fruits. The reason for that, to retain their color and taste. Lactic acid, C3H6O3. As shown on the screen, CH3CHOHCOOH has IUPAC name 2-hydroxypropanoic acid. It is found in milk as a result of the effect of enzymes secreted by a certain kind of bacteria on milk sugar. It is generated in human body as a result of hard effort and causes constriction of muscles. Ascorbic acid, which is vitamin C. The human body needs vitamin C in small quantities. It is found in acidic substances like fruits, vegetables, and green pepper. It is hydrolyzed by heat and the effect of air. The lack of vitamin C leads to the infection of escargot disease and the decrease in the biological function in the human body. Salicylic acid. We have given reason in this point. Salicylic acid is used in the manufacture of cosmetics to skin because it makes it more soft and protect against sun rays. My dear students, salicylic acid is used from 1829 in the treatment of cold disease and headache before using aspirin. And we have given reason in this point. Salicylic acid is not used to treat cold disease. The reason for that because it causes bleeding of stomach. Amino acids or organic acid derivatives. The simplest member of amino acid is glycine, which is known as also amino acetic acid. It is formed by replacing one hydrogen atom in the alkyl group of the acid molecule by an amino group, NH2. As shown on the screen, if we bring acetic acid and we remove one hydrogen in it and replaced by amino group, see it forms glycine, which is the simplest amino acid. Amino acids are numerous in nature, but only 20 of them exist in natural proteins. The amino acids which form proteins are of the alpha amino type. That is, here as shown on the screen, the carbon that attach to the amino group and contains a carboxylic group called alpha carbon. Here proteins are considered as polymers of amino acids. For example, insulin is a protein molecule. Its molecular mass is 6,000 and consists of 51 molecules for 16 amino acids. The molecular mass of some proteins reaches 1 million in some complicated enzyme. We are going to discuss some questions. Write the scientific term. Organic compounds having one carboxyl group or more. Yes, the answer is carboxylic acid. Reaction of acid with alcohol in the presence of concentrated sulfuric acid. If you think about it, yes, it will be ester formation. Reactions of carboxylic acid with sodium carbonate or bicarbonate. If you think about it, yes, it will be acidity test. Natural polymers arise from the condensation of alpha amino acids with each other. If you think about it, yes, it will be proteins. The number of carboxylic group in an organic acid. If you think about it, yes, it will be basicity of acids. Polymers of amino acid. If you think about it, yes, it will be proteins. Next type of question is choose the correct answer. The carboxyl group is composed of what groups? Hydroxyl and amino, hydroxyl and formyl, hydroxyl and carbonyl. No correct answer. If you think about it, yes, it will be hydroxyl and carbonyl. All these acids are monocarboxylic acids except what acid? Propanoic, formic, ethanoic, phthalic. If you think about it, yes, it will be phthalic, which is dicarboxylic acid. What acid is an example of dibasic aromatic acid? Benzoic, phthalic, formic, oxalic. If you think about it, yes, it will be phthalic acid. Next point. All these compounds give effervescence with sodium bicarbonate except what? HCOOH, C6H5COOH, HCOOCH3, CH3COOH. If you think about it, yes, it will be C. The reason for that, my dear student, is the only ester from these compounds, while the others are organic acids. Next point. Toluene is oxidized by air in the presence of vanadium pentoxide and give what? Benzoic acid, phthalic acid, acetic acid, all of them. If you think about it, yes, it will be benzoic acid. Next point. Esters usually have pleasant odor. Therefore, they are used in manufacture of what? Artificial color, flavors, polymers, detergent. If you think about it, yes, it will be flavors. Next point. Glycine is considered from what kind of acid? Hydroxy acid, aromatic acid, amino acid, fatty acid. If you think about it, yes, it will be amino acid. Next point. Insulin molecule is composed of 51 amino acids, and it is considered example of what? Proteins, fats, carbohydrates, oils. If you think about it, it will be proteins. Reduction of acetic acid by hydrogen in the presence of copper chromate gives what? Copper acetate, chromium acetate, ethanol, acetaldehyde. If you think about it, yes, it will be ethanol. Next point. Chemical formula of ester obtained from reaction of acetic acid with methanol is what? Is it CH3COOC2H5, CH3COOCH3, C6H5COOCH3, HCOOCH3? If you think about it, yes, it will be CH3COOCH3. Next point. All these chemical formula don't represent esters except what? CH3OCH2COCH3, C2H5COC2H5, CH3OC6H5, CH3COOC2H5. If you think about it, yes, it will be CH3COOC2H5. My dear students, we have finished our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.